Welcome students. Today we are going to discuss about the very important properties of the mentioned in the chemistry, and these properties are the ionization energy and electron affinity and electronegativity. Students, today we only discuss about the ionization energy. Before we proceed to our topic, it is very necessary to look back for the formation of the ion. Students, we already discussed it, but we have a just bird eye view in the formation of the ion, and that is the addition or the removal of the electron from a neutral atom, from a gaseous isolated atom, give birth to ion. Students, you know that when an atom is in a isolated gaseous phase, then there is no any external influence on that isolated atom. So we can remove or we can add the electron in that neutral atom to get the ion. Students, as you know that ion is divided into two types, that is the cation and that is the anion, on the base of addition or the removal of the electron, or the basis of the different charges. As you know that the charge on the cation is the positive charge and the charge on the anion is the negative charge. Students, as you know that for the cation formation, the process is the endothermic, and in the formation of the negative ion, the process is the exothermic. Endothermic means the energy is absorbed, and endothermic means the energy is released. So you know that when we have studied, when we discussed about the ion, we only get the information about the positive charge, about the negative charge, and about its exo and endothermic process. We didn't involve the energy in the formation of the positive or the negative ion. Here we are going to involve the energy. Either energy is increased, energy is absorbed, either energy is released. So as far as these two types of the energies are concerned, we will discuss the ionization energy or ionization potential. These are both. Secondly, electron affinity. Students, the formation of the cation as the energy is absorbed is concerned to that type of the energy, ionization energy or the ionization potential. And as far as the energy is released, it is concerned to the electron affinity. Today we will only discuss the electron ionization energy or the ionization potential. The students, ionization energy or the ionization potential, as we have discussed that the energy in that property is involved, so it can be defined as the minimum amount of energy required to remove the electron from an isolated gaseous atom to form ion is called as ionization energy or ionization potential, and this process is called as the ionization. For example, We have the magnesium isolated gaseous atom, and the electron is removed from that and we get the positive ion. And in this record, we have required the minimum amount of energy as the 738 kilojoule per mole. Similar is the case when an isolated gaseous hydrogen atom is taken and we remove the electron from that atom, then the energy required to form the positive hydrogen ion, that will be the 1313 kilojoule per mole. Students, one thing is also important to know that these energies for the magnesium and for the hydrogen is required to remove the one electron from each of the atom, so that energy is called as the first ionization energy. Energy is termed as the first ionization energy. The energy required to make the unipositive ion of the hydrogen will be 1313 kilojoule per mole, and the energy required to form the monopositive ion of the magnesium will be 738 kilojoule per mole. Students, we go ahead, we can remove the electron from the unipositive ion and the dipositive ion, and these energies are termed as the second ionization energy for the unipositive ion when the electron is removed. Similarly, for example, I say that the magnesium positive, a unipositive ion, when an electron is removed, another electron is removed from that unipositive ion of the magnesium, then the energy required will be 735 kilojoule per mole. Similar is the case for when we remove the energy, when we remove the third electron from the dipositive ion of the magnesium, then we will have the much more energy for that, and that energy is the 7 Students, that energy is second ionization energy, and that is the third ionization energy, the ionization potential. So these energies, that is the second ionization energy and the third ionization energy, are termed as the higher ionization energies. Higher ionization energies. Students, these higher ionization energies are the different values of the ionization energies of the different elements regarding the first ionization energy, regarding second ionization energy, regarding third ionization energy. We can assume the different other properties of that element, and these other properties which are concerned to the ionization energies, different ionization energies of the element, from the unipositive ion to dipositive ion and dipositive ion to tripositive ion, we can find the other properties. These are the metallic character. Metallic character is the property of the element which can be assumed from the ionization energies, and if the ionization energy of an element is very low, if the ionization energy of the element is very low, then that element will be the metal. And if the ionization energy of the element is intermediate, the element will be the metallides. If that ionization energy is very high, the element will be non-metal. The element will be non-metal. Another property we can discuss, we can assume from the values of the ionization energies is the valency of the atom. Valency of element is that when there is a long gap between first ionization energy to second ionization energy, then that atom will be monopositive. Means it will have the valency of the 1. It will have the valency of 1 valency. If the gap between the two ionization energies, that is first and the second, is not high, that is low, then we say that the valency of that element is the divalent, and so it has the valency of the 2. And similar is the case for the third ionization potential and third valency. It depends upon the gap of that values. Like for the concern, if we studied the magnesium first monovalent, magnesium divalent, then we see that there is a long gap between the third ionization energy for the magnesium, and that is the 7735 kilojoule, and it is not possible that magnesium has the valency of the 3. That is not possible. But the gap between the second ionization energy and the first ionization energy, which is 738 kilojoule per mole, that is not a big gap, that is not a more gap. So it is convenient to understand that point. Okay, the magnesium has the valency of the 2, that is magnesium is divalent. So we can assume the various properties from the ionization energies that I have told you about the metallic character, about the valency of the elements, judgment of the valency, index of the element. We can take the different indexes like the metallic character, indexes like the valency of the elements. Students, after that, now we will discuss the various factors which influence on that ionization energy. These factors are: first, atomic radius. Atomic radius is responsible for the value of the ionization energy, because in that sense, if the atomic radius is larger, then ionization energy will be less. If the atomic radius is smaller, then ionization energy will be high. You know that. Why so? And that can be explained in that examples. Let's suppose, because when the size of atom is very slow, the size of atom is small, then the distance between the valence electron and the nucleus is very small, and the influence of that nucleus for that valence electron is much more. So much energy is required. Much energy is required. But when the size of atom is very large, then the influence of the nucleus for the valence electron is the less. It has the less influence for the valence electron. So less amount of ionization energy will be required to remove the valence electron of that atom. Similarly, we can say that the nuclear charge is also influence the value of the ionization energy, as more the nuclear charge, more the nuclear charge, the more will be the attraction for the valence electron, and much more energy will be required to remove that electron. So that less the nuclear charge, have the less influence for the valence electron, and less ionization, less energy will be required. Less energy will be required, and the less ionization energy will be for that atom. That all these terms will be discussed in detail in our later studies. We have just a look for their understanding. Second is the shielding effect. Shielding effect, you know that the successive shields for the orbitals which are screening the influence of the nuclear charge for the last shell, for the valence shell. If these are the more shields that will screen the influence of the nucleus for the valence electron, so we will have the less amount of energy to remove that electron. Means the ionization energy will be the less when more shielding effect. More shielding effect. If the shielding effect is less, like that example, if the shielding effect is less, then much more energy is required to remove the valence electron, because there is less screening of that single orbital in between the valence orbital, valence shell. So we can say that more the shielding effect, the less will be the ionization energy. Less shielding effect, more will be the ionization energy. Similar is the case with the nature of the orbitals. the orbitals which are very close to the nucleus, the orbitals like K, L, M and N. The K is very close to the nucleus. Here much attraction is in between the nucleus and the electron. So we can say that much more energy will be required to remove the electron from that orbital. Similarly, that K is away from the nucleus, so it will be less energy will be required as compared to the K. And similarly, the ML is the more away from the nucleus, and it will have the less energy to remove the electron as compared to the L. And if we consider the N, it is the more away from the nucleus influence for the valence electron. Similarly, the less energy will be required to remove the electron from the n orbital. If we consider it with reference to the orbitals, that is the S, P, D and the F. The S is the more energy, P is away, D is further away and F is the further away from the nucleus. So we can say that nature of the orbital also influence value of the ionization energies. Now all these studies, after comprising these all studies, we will take a view on the periodic table. Okay, what is the variation of the ionization energy in the periodic table? And that variations are studied in the two different modes, and one of is the along the periods and along the groups. The periodic table, as you know, that trends along periodic table. Two things are taken, that is along the groups and along the period. As you know that the vertical columns are called as the group and horizontal rows are called as the periods in the periodic table. When we go from top to bottom along the group, the atomic size is going on increasing. As the atomic size is going on increasing gradually, the value of the ionization energy is going on decreasing. The reason behind this is that I have already told you the factors which influence the values of the ionization energy, that is the atomic radius, that is the nuclear charge, that is shielding effect and nature of the orbital. As along the group, the size is going on increasing. So the first atom has a smaller atomic radius, more nuclear charge, less shielding effect. So the ionization energy is greater for that, high. And as we see the lost element in the bottom, the atomic radius is going on increasing, shielding effect is increasing, which influence the less attraction for the less nuclear charge to the valence electron, and the less amount of the energy is required. So the value of ionization energy is decreased. Ionization energy is decreased. Along the bottom, along the group, top to bottom, the ionization energy is going on decreasing due to the factors which are influencing the value of the ionization energy, and that is the atomic radius, that is the nature of the nuclear charge, that is the shielding effect. And it will be very convenient to study for all the groups along the in the periodic table, and that trend will be observed. As far as along the periods, as I have told you that the periods are taken as the horizontal rows along the in the periodic table are called as the periods, and in this way the ionization energy is going on increasing. The reason behind that factors that along the period the atomic size, the atomic radius is going on decreasing. As the atomic size is going on decreasing, then the same factors will influence on these, and the ionization energy is going on decreasing. And the ionization energy is going on increasing because nuclear charge is going on increasing from left to right, the atomic radius is going on decreasing from the left to right, and the shielding effect is going on decreasing from left to right. So we can, that is the trend of the ionization values in around the periodic table. But one thing is abnormal, this trend for the groups 3rd A and group 4th A is abnormal. The reason behind this is, if we take the electronic configuration of these two groups elements, then we will be able to understand why their ionization values along the period, along the group is abnormal. So it will be studied later. Thank you very much. But after that, if you find any problem about that topic, you may ask and we will reply you, inshallah. Thank you.